Okay, I have here a point 3, -4, and that point is on the terminal side of an angle theta. So let's draw the angle theta. We have the initial side, which if it's in standard position would always be going along the positive x-axis, and we have the terminal side, which is said to have the point 3, -4 on it. So the angle that we're talking about is this angle right here. That's the angle theta that we're looking for. So what I'm going to do is I'm going to go ahead and I'm going to create a reference triangle. And I'm going to do that by dropping an altitude. When I say drop, well, the altitude is vertical directly towards the x-axis. So altitudes are always vertical lines. And there I've dropped the altitude, which creates my reference triangle. So what I'm going to do is I'm just going to outline the reference triangle in green so I can blow the whole thing up here. There's the reference triangle outlined in green. And there's an angle on the inside of my reference triangle that's related to theta. This angle right here on the inside of the reference triangle is related to theta. Actually, if you add that angle to theta, you'll get 360. So this angle, theta prime, I'll call it, theta prime. And that angle is the difference between 360 and theta. So if you add that angle to theta, you will get the full revolution, 360 degrees. So let's look at it. Let's blow it up. So we have, this is the reference triangle. The angle theta prime is over here, theta prime. And we have a right angle in the corner here. And we know some things about theta prime. For instance, the adjacent side, the side adjacent to theta prime, is 3 units long because the x value of that point is 3. So I go 3 over to get to that altitude. I also know the adjacent side is 3 and the opposite side is 4 because I went 4 units down. That was -4, 4 units down to get to the point. So that ordered pair gives me the adjacent side as the x value and the opposite side as the y value of that reference angle. And then I can also find the hypotenuse by using the Pythagorean theorem. The Pythagorean theorem would say that one leg squared plus the other leg squared would equal the hypotenuse squared. And the hypotenuse is what I'm calling c. The hypotenuse is also the radius of that circle. It's also the radius of that red circle. So let me see. We have 9 plus 16 equals c squared, or 25 equals c squared, and that means that c is 5. So this side over here, or the hypotenuse, is actually 5. So I can find all 6 trig functions rather easily. So for theta prime, which will have the same trig functions as theta, except for the sign, that is. So because I want to include the signs, I'm going to keep this as -4 as the opposite side. So the sine of theta would actually be opposite, which would be -4, because it's a -4 across, divided by 5, so opposite over hypotenuse, which is basically the y value of that point over the radius of that circle. And then the cosine of theta is going to be adjacent, which is 3 over 5, which is the x value of the point over the radius of that circle. And the tangent of theta is opposite, which is -4 over adjacent, the y value of the point over the x value of the point. All right, and then I'm moving on to the other trig functions, the cosecant, secant, and cotangent, which are just the reciprocals of the first 3. So the cosecant is the reciprocal of sine, 5 over -4. The secant is the reciprocal of cosine, 5 over 3. And the cotangent is the reciprocal of tangent, 3 over -4. And those are the 6 trig functions. The last 2 parts of this question ask me to find the actual angle theta. In order to find theta, what I'm going to do is I'm going to find theta prime, which is how much more I need to go to get one full revolution, I'm going to find theta prime, the blue angle, and I'm going to subtract it from 360 degrees, or 2 pi radians. Alright, so how am I going to find theta prime? Well, let's take this reference triangle and look at the arc. Look at the arc. What is it? Oops. Let's take this reference triangle and look at the arc tangent of theta prime. Alright, here we go. So we're looking for the arc tangent of theta prime. So theta prime, or not the arc tangent of theta prime actually, theta prime is equal to the arc tangent of the opposite side of this reference triangle, which is 4, over the adjacent side of the reference triangle, which is 3. So the ratio that represents the tangent, 4/3, is the same ratio that's going to give me this angle in the reference triangle. So let's go ahead and let me see. When I do this on my calculator, when I do it in radian mode, I get that theta prime, that reference angle, is equal to 0.9273. Now remembering that this is what I would need to add to the original angle theta to get 360, I can find theta then by taking 2 pi and subtracting it from it, 0.9273. which is going to give me 5.3559. And that's my answer for the first one here, the radian measure, 5.3559. Then I'm going to do the degree mode. Change my calculator to degree mode, and then I'm going to find out here that theta prime in degree mode would be 53 degrees. So degree modes give me 53 degrees. And once again, in order to find theta itself, if I have the reference angle that's in the, and theta is in the 4th quadrant, I have to subtract from 360. So subtract from 360 the 53 degrees, and we get 307 degrees. So the answer for the last part, 307 degrees. And just by knowing one point on the terminal side of an angle, I have found all the 6 trig functions and the angle itself.